Hello everyone, I am Dr. Ashish Bansal. I welcome you all to the second video of this series. In this video, I shall give you the solutions of question number 2 to question number 8 of ISC 12 Mathematics 2024 board paper. This is question number 2. It's a 2-mark question and there is an internal choice. In the first part, we are given a function f from r minus minus 1 by 3 to r minus 0 defined by fx equal to 5 by 3x plus 1 and the function is given to be invertible. We have to find the inverse function. So given this function f to be invertible, we can say that f inverse from r minus 0 to r minus 1 by minus 1 by 3 exists. So let me take an element y in the codomain of f. And since f is invertible, that implies f is onto. That means there is an element x in the domain such that fx equal to y. Now fx equal to y implies 5 by 3x plus 1 equal to y. Upon simplification, we get x equal to 5 minus y by 3y. Now I can replace this x by f inverse y because by definition fx equal to y if and only if x is equal to f inverse y if f is invertible. Hence f inverse x is equal to 5 minus x by 3x. Moving to the second part, we are given a function f from r to r defined by fx equal to 2x minus 7 by 4. We have to show that f is 1 1 and onto. Now given this function, to show that f is 1 1, let us take two elements x1 and x2 in r. Now fx1 equal to fx2 implies 2x1 minus 7 by 4 equal to 2x2 minus 7 by 4. Upon simplification, we get x1 equal to x2. This implies f is 1 1. In order to show that f is onto, let us take an element y in the codomain. Now fx equal to y implies 2x minus 7 by 4 equal to y. Upon simplification, we get x equal to 4y plus 7 by 2. Now this is a real number, for every y a real number. This implies for every y there exists an x such that fx is equal to y, hence f is onto. This is question number 3. It's a 2-mark question. In this question we are given a determinant and we have to find its value without expanding it. So if you look at this determinant carefully, in C3, the third column, we can apply the distributive law and get alpha beta plus alpha gamma, beta gamma plus beta alpha, gamma alpha plus gamma beta. Now applying this operation, C3 goes to C3 plus C1. We are adding the values of C3 with the corresponding values of C1. So we get the C3 as alpha beta, beta gamma, alpha gamma in all the three terms. Now we can take this value alpha beta plus beta gamma plus alpha gamma common from C3 to get to this determinant. Now if you look at this determinant carefully, the second column and the third column, they are identical. So the determinant is 0, hence the value of the given determinant is 0. Question number 4, it is a 2-mark question. Again there is an internal choice in this question. We have to determine the value of k for which the following function is continuous at x equal to 3. This is the function which is given to us. Now in order to find the continuity at x equal to 3, let us first write what is f3. f3 is k. Let us find the right hand limit of the function at x equal to 3. So replacing fx by x plus 9, then putting x equal to 3 plus h, we can get the right hand limit as 12. Similarly, we can compute the left hand limit to be 12. So for continuity at x equal to 3, the right hand limit and the left hand limit and the value of the function at 3 should be equal. So this implies k equal to 12. The second part of question number 4 is find a point on the curve y equal to x minus 2 whole squared at which the tangent is parallel to the chord joining the points 2 0 and 4 4. So given curve is this, let alpha beta be the required point on this curve. Substituting these coordinates in the given equation, we get beta equal to alpha minus 2 whole squared. Now let us differentiate both sides of given equation first. We get dy by dx equal to 2x minus 4. the value of dy by dx at alpha beta is 2 alpha minus 4. Now we are given that the tangent at alpha beta is parallel to the chord joining 2 0 and 4 4. This means the slope of the tangent should be equal to the slope of the chord. Slope of the tangent we have already computed, it is 2 alpha minus 4. So we get that this value. Slope of the chord, this chord is passing through these 2 points, and we have the formula for slope y2 minus y1 by x2 minus x1. So this results in, upon simplification, alpha equal to 3. Now putting this value of alpha in this equation number 2, we can get the value of beta as 1. Hence the required point is 3, 1. Moving to the next question, number 5. It is a 2-mark question. We have to evaluate this definite integral. Let I equal to the given integral. Let us now use a property of the definite integral, that f of integral a to b fx dx equal to integral a to b f of a plus b minus x. So 0 plus 2 pi minus x. So we replace x by 2 pi minus x. It is 1 upon 1 plus e raised to minus sin x. Multiplying numerator and denominator by e raised to power sin x, we get this integral. Now adding the two values in equation number 1 and equation number 2, we get 2y equal to this integral plus this integral. Now we can combine these two integrals and simplify to get the value of I as pi. Question number 6, it's a 2-mark question. We have to evaluate the probability of A union B, and we are given that 2 times probability of A equal to probability of B, which is equal to 5 by 13, and probability of A given B is 2 by 5. Now given these two values, we can extract the values of PA and PB as 5 by 26 and 5 by 13 respectively. Given that PA given B equal to 2 by 5, PA given B is PA intersection B by PB. So this implies P of A intersection B as 2 by 13. Now in order to find PA union B, we have this formula PA plus PB minus PA intersection B. We already know the values of PA, PB and PA intersection B. Hence PA union B is 11 by 26. Question number 7, it's a 4-mark question. We are given that y equal to 3 cos log x plus 4 sin log x. We have to show that this expression exists. So given y equal to this, call this as first equation. Differentiating both sides with respect to x, we find dy by dx. It's easy to compute. Now there is x in the denominator. We can take this x to the right hand side, to the left hand side, to get x dy by dx equal to minus 3 sin log x plus 4 cos log x. Now differentiating this equation again with respect to x, we get the left hand side becomes this quantity, right hand side becomes this. Again there is an x in the denominator. We can take this x to the left hand side to get this value. Now if you look at the right hand side now, it is minus 3 cos log x minus 4 sin log x, and this is the value of y. So it is equal to actually minus y, which results in the required expression. Question number 8, it's a 4-mark question. There is an internal choice. The first part is we have to solve a given inverse trigonometric equation for x. So we are given that sin inverse x by 2 plus cos inverse x equal to pi by 6. Taking this cos inverse x to the right hand side, then sin to the right hand side, we get x by 2 equal to sin pi by 6 minus cos inverse x. Now use the formula for sin a minus b, sin a cos b minus cos a sin b to get this. You know sin pi by 6 is half, cos pi by 6 is root 3 by 2. Now cos inverse x is equal to sin inverse root 1 minus x square. It's a standard identity. Now this becomes root 1 minus x square. Now it can be simplified to get root 1 minus x square equal to 0, which implies x square equal to 1 and x equal to plus minus 1. And it can be easily seen that x equal to 1 satisfies the given equation, whereas x equal to minus 1 does not satisfy first. Hence x equal to 1 is the required solution. Question number 8, second part, it's a 4-mark question. we are given that sine inverse x plus sine inverse y plus sine inverse z equal to pi. We have to show that x square minus y square minus z square plus 2yz root 1 minus x square equal to 0. Now sine inverse x plus sine inverse y plus sine inverse z equal to pi, we are replacing sine inverse x by cos inverse root 1 minus x square. Similarly sine inverse y and sine inverse z. Taking this x term on the right hand side. Now we apply the formula for cos inverse a plus cos inverse b to get this. Now cos can be taken to this side. We are left with this term root 1 minus y square root 1 minus z square. This is y and this is z, is cos of pi minus this quantity. Now simplifying this, we get the required result. We get this expression. On squaring both sides and simplifying, we get the required expression. Thank you so much. For rest of the solutions, visit the next videos.